Now, let's talk about the, the isotropy and anisotropy of motions. When we talk about anisotropy and isotropy of motions or speeds, we talk about differences dependent on direction. Towards different directions, we have different motions and speeds. Let's talk about the anisotropy and isotropy of speeds and motions regarding light. Suppose that this source of light is not producing any light, and at some point it emits light towards all directions. And so we have an expanding wave of light. All the photons that are at the wavefront are at the same distance from the source as they are moving away from the source, because at first they are close to the source, then they are moving away from the source towards all directions. If as they are moving away from the source are always at the same distance from the source, we will say that all the photons that are at the wavefront are having the same speed relative to the source. In a different situation where this source emits light towards all directions, but we have this situation where the source does not remain at the center of the wave of light that is moving away from the source. The photons that are at the wavefront of the light wave are not having the same speed relative to this specific source. They are having the same speed, the photons that this source produces. The photons that are at the wavefront are having the same speed relative to this source because they are always at the same distance from the source as they are moving away from the source. But if as this light source produces the wave of light and we have photons at the wavefront are moving away from the source, as they are moving away from the source are not at the same distance from the source. This is closer to the source, this is farther away from the source. This is anisotropy of the motion of the photons relative to the source, not relative to anything else. Relative to the source. This is isotropy of the motion of light relative to the source. To understand in any situation which of the two is happening is something that must be evaluated independently from anything else, independently from the fact that a source of light is stationary or not relative to a human. So this is isotropy of the motion of light relative to the source. This is anisotropy of the motion of light relative to the source. A significant note. We have here the emission of many photons towards many directions. But we also talk about it as one light wave, meaning that we regard the emission, the simultaneous, because the photons that are at the wavefront are emitted simultaneously. But this simultaneous emission of many photons, thousands, millions photons from the source, we regard it as one event, as one light wave. when they start the emission of light and we have the wavefront, we have a simultaneous emission of many photons towards all directions, and we have the wavefront. But to evaluate in any situation which of the two is happening, whether the source is at the center or not, is something that must be evaluated independently from anything else, independently from the motion of the sources relative to something else, and independently from the fact that a source of light is stationary or not relative to a human. Let's say that we have a human on a hill. On the top of the hill, this is the human. And the human has on under of one of his legs, it has 4 balls. 1, 2, 3, 4 balls. He has his foot above the balls here, and the balls are not moving. At some point, the human raises his foot, and the balls are moving. So the one ball towards this direction, the one towards this direction, the one towards this direction, the one towards the other direction. This is the one ball, this is the other ball. Also, this is the 3rd ball, and we don't see the ball that it is on the back of the hill. In one motion, the human raises his foot, and the ball started to move. If, as they are moving away from the human, are always at the same distance from the human, we will say that these 4 balls have the same speed relative to the human. If they are not at the same distance away from the human as they are moving away from the human, we will say that these 4 balls don't have the same speed relative to the human. If I have 4 balls on my hand, I am on the top of the hill, and I throw one ball towards one direction, and after a few seconds I throw the other ball towards another direction, and after a few seconds the other ball towards a different direction. Of course the 4 balls will have different distance away from the human, because I did not throw them at the same time or simultaneously. But here we have a situation where the human has his foot on the 4 balls, raises the foot, one motion, and the balls start to move at the same time, simultaneously. So, as they are moving, if they are at the same distance, there is no need to measure their speed with a different way. If one is here, one is here, one is here, and the other on the back, we will say that all balls have the same speed relative to the human. But if, for example, this is further down here, we will say that this ball has a larger speed relative to the human than these 2 balls. We don't need to know anything else. We don't need to make some calculations regarding the motion of this ball, because we know that all the balls are left to the human when the human raises its food. And so we understand that this ball is moving faster than these two balls relative to the human. Relative to the human, that's why it is further away. These two balls, which are at the same distance from the human, have the same speed, these two balls, relative to the human. But they are having smaller speed relative to the human than this ball. This ball has larger speed relative to the human than these two balls. We don't need to make any calculations. The only thing that we know is that these four balls started to move when the human raised his foot, and they started to move. So when this is happening, we have anisotropy of the motion of the balls relative to the human. But if the balls are at the same distance always relative to the human as they are moving away from the human, we say that we have isotropy of the speeds of the balls relative to the human. But if this is further away from the human, this is anisotropy of the motion of the balls relative to the human, not relative to something else, relative to the human. Now, something regarding the relativity of simultaneity. No, the relativity of simultaneity is about events that are happening at different locations. When we are talking about events that are happening at one location, at the same location, here for example, there is no relativity of simultaneity. For example, if we have another hill here, and there is another human, and this human raises his hand, and this human raises his hand. Because we are talking about events that are happening at different locations. People that are at different locations, for example, a person here and a person here will have different ideas about which of the two humans raises his hand first, because the relativity of simultaneity has to do with events that are happening at different locations. But when we are talking about event that is happening at one location, at the top of the hill, where we have four balls, anyone can understand, regardless of his location, regardless if he is at the top of the hill or if he is far away from the hill, he can understand that the four balls left this human simultaneously. The relativity of simultaneity has to do with events that are happening at different locations. When we are talking about events that are happening at the same location, the order of events, or if these events are simultaneous events, is the same for every human on the universe. Now let's see some errors of the scientific community regarding the position of the source of the light compared to the waves of light that the source emits. using the Doppler effect. Let's say that this source is stationary relative to the human. The scientific community believes that if there is no relative motion between the human and the source, this is the source, this source is always at the center of the waves, which is not the reality. What we see here, which is the idea of the scientific community about reality regarding the motion of light compared to the source, is wrong. We have here another human and another source. The scientific community, when there is no relative motion between the human and the light source, they think that this is what is happening, that the source is at the center of the waves. When they say that the source is moving towards the human, they say that this is what is happening. The source does not remain at the center of the waves. This is the example that you will see when the scientific community tries to explain the Doppler effect and says that the source is moving towards the human, but when they say that the human is moving towards the source, they keep the source at the center of the waves. In both situations, all that we have is relative motion between human and source, here and here. Both objects, human and the light source, here and here, are at an inertial reference frame, and both are saying that they are stationary. So why the scientific community present these two things completely differently? What I'm saying is that whether or not a light source is at the center of the waves, of the light waves that it produces, is something that has nothing to do with the motion of the source relative to a human. It is something that must be examined independently from anything else. Because here we have two exactly the same situations, but they're presented in a totally different way. Because this is what you will find. These three things you will find in a situation where there is no relative motion between the light source and the human. You always see the light source at the center of the waves, which is completely wrong, because the majority of the light sources on the universe are not at the center of the waves. This is totally wrong. The majority of the light sources on the universe are not at the center of the light waves that they are producing, and has nothing to do with the motion of the source relative to a human. If we consider the human that is on the move or the source is on the move, whether or not a source of light is at the center of the light wave that it produces is something that must be evaluated independently from anything else. Imagine that these are perfect circles. But this is the reality. Reality. This is not reality. This is not reality. This is not reality. This is the reality. The reality is that we have a human and a source stationary relative to each other, but the source is not. The source is not at the center of the waves, of the light waves. And this is happening, but we do not have Doppler effect. How we don't have Doppler effect, I will explain it in another video. But this is a reality, because the majority of the light sources of the universe are not at the center of the light waves they are producing, even if they are stationary relative to a human, and we don't have Doppler effect. We will find different energy of the photons, even though the source emits identical photons towards all directions. We will not find the same energy on all the photons, even though this source emits the same identical photons towards all directions. We will not find the same energy to all these photons. I will show you another example in order to help you understand why the reality is that most of the light sources on the universe are not at the hypothetical center of the light wave that they have emitted, and why the ideas, the belief of the scientific community is wrong. When the scientific community wants to present the Doppler effect, and they have a light source and a human stationary relative to each other, they always place the light source at the hypothetical center of the light wave that the source emits. For example, we have a human and a light source, stationary relative to each other. The human and the light source are stationary relative to each other, and the source and the human are in an inertial reference frame, so no acceleration. In this situation, and you can search on the internet, or you can look at any book you want to look, in all the pictures that you will find, the scientific community places the light source at the hypothetical center of the light waves. Imagine that these are perfect circles. These are the waves of light that the light source emits towards all directions. And when we are in a situation when the scientific community wants to depict a situation where there is no relative motion between a human and a light source, they always place the source at the hypothetical center of the light waves that it emits towards all directions. But this is absolutely wrong. Whether or not a light source is at the hypothetical center of the light waves that it has emitted is something that must be evaluated independently from anything else, independently from the fact that the source is stationary relative to a human, or a human is stationary or on the move relative to a source. What you see here, where there is no relative motion between the human and the light source is wrong. It is wrong thinking, believing that the light source is at the center of the light waves. But this is the picture, this is the idea, this is the belief that the scientific community has. This is the picture that you will find if you search on the internet, if you look at any book, whether it is a book on a university or any other book. And I have shown you already some ideas why this is not the reality. And I will give you another example why this is not the reality. Imagine that we are in a football stadium or in a soccer stadium, as they call it in the United States. A pitch which is like this, and it is this side is in average 70 meters, and this size is 105. And suppose that around the lines, the outer lines of that pitch, around that pitch there are 100 humans. 100 humans, and each human is holding in his hand, like this, a device that has a light bulb. That light bulb emits light towards all directions. So 100 humans are in various locations around this field. 100 humans, and each human has in his hand a device that has a light bulb that it emits light towards all directions. These are all stationary around this football pitch. Now, we give a signal to all these 100 humans, and they start to move inside this field at a constant speed. Meaning, for this can go this direction, 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 in various directions and speeds. Not all the humans in the same direction and in the same speed, at different directions and speeds, but each human moves at a constant speed. Meaning that it is in an inertial reference frame, is not under acceleration. Each of these 100 humans is in relative motion at constant speed with the other 99 humans. 100 humans, and each human has in his hand a device that has a light bulb that it emits light towards all directions. And the question is, can all 100 light bulbs to be at the center of the light waves that they are emitting towards all directions? The answer is no, because there are two possibilities. Either all of the 100 light bulbs are not at the hypothetical center of the light wave that they are emitting towards all directions, or the other possibility is that only one of the light bulbs that each human has, only one of these 100 light bulbs can be located at the hypothetical center of the light waves that it emits towards all directions. And here is the important fact, the important realization. Each of these light bulbs, which are not at the hypothetical center of the light waves, it is stationary relative to a human. Meaning that at least 99 of the 100 humans, they have a light bulb in their hands and even though the human and the light source, the light bulb, the light source, are stationary relative to each other, the light source, the light bulb, is not at the center of the waves. Meaning that this idea that when we have a human and a source stationary relative to each other, the idea that the source is at the center of the light waves because there is no relative motion between the human and the source, this idea is wrong. This is not the reality. The idea that, for example, you are this human and you have a light source stationary relative to you, thinking that because the light source is stationary relative to you, it is at the hypothetical center of the light waves that it emits towards all directions. This idea is absolutely wrong. We have here, from the 100 humans, at least the 99 humans, they are in a situation where they are stationary relative to a light source, the light source that they have on their hand. They are stationary, the humans, relative to the light source, or the light source stationary relative to the humans. But for at least the 99 humans, the reality is that the light source is not at the center of the waves. Meaning that this idea, that this is the reality, this belief of the scientific community that this is the reality, is absolutely wrong. This is not the reality. The reality is that the majority of light sources on the universe are not at the hypothetical center of the light waves that they are emitting towards all directions, meaning that we have humans and light sources stationary relative to each other, and the light source is not at the center of the waves. This is not reality.